front, right. Try the 3 to 5 and roll if I don't think.
Okay, a very good morning, everyone, and welcome to another HSMA training day. So this morning, I'm going to be talking to you about one of my particular research interests, which is the field of natural language processing, which I think is a really interesting field, and I think has a lot of potential, particularly for those working in health and social care and policing, to be able to apply some of these methods to some really useful information and data that you store, particularly sort of free text data. And so this morning, as with most of these kind of introductory sessions, I'm going to be sort of introducing you to the core principles of natural language processing. A lot of this stuff isn't stuff that you have to deal with directly, but is stuff that's going on underneath the bonnet, and you need to understand some of these core principles if you're going to be working with natural language processing methods in order that you can analyze the outputs effectively. And as you'll see when we come on to the future sessions in this module, where we look at named entity recognition and sentiment analysis in particular, particularly with named entity recognition, you'll see how really easy it is to actually do that kind of thing. But the real art comes from refining it and interrogating it in such a way that you're able to draw insight from that. And so it's important that you understand the core concepts that I'm going to be talking about. So I apologize. There's going to be quite a bit of grammar stuff this morning, and I know everybody loves grammar. So Mike, by the way, won't touch this session with Barbara. He hates grammar. But yeah, it's not as though you're going to have to work with this directly. So don't worry too much about that. But at the same time, you'll need a sort of basic grasp of what's happening underneath the bonnet. But I think there's real potential in natural language processing, and particularly as with last week's session where we looked at some of the core concepts of machine learning. Natural language processing, as we're going to see today, borrows a lot of stuff from that, and there's a lot of AI-based methods that we're going to be showing you. So this is basically machine learning for words. Is kind of what natural language processing is in terms of what we're going to teach you. So let's think about what we mean by natural language processing first. So natural language processing, or NLP, as it's commonly abbreviated, is basically focused on the way in which human language and computers interact. And NLP is a kind of coverall term for two kind of very different sides to what we mean by that and what that can mean in terms of human language and computers interacting. So traditionally, when we talk about natural language processing, particularly over the last couple of decades, it's been all about really trying to get computers to kind of understand natural language. So can you communicate with a computer and get it to understand you? And a lot of natural language processing historically has kind of focused on that side of things. So things like speech recognition, or building an AI that you can talk to and it will talk back to you and kind of show some sort of cognition. And indeed, there have been AI competitions that have been based on people building stuff that allows you to talk to a computer and it giving the illusion, at least, that it's talking back to you. And we encounter these kinds of things in our everyday lives all the time. Many of us have digital personal assistants, either things like the Amazon Echo or whatever, or even things on our phone, our little digital assistants on our phone. So speech recognition has become a kind of standard part of our lives. But even things like chatbots, which I'm sure we all love when we're trying to sort of resolve a problem with a company, that's all based on natural language processing. Although I have to say, in a lot of cases, that particularly the chatbot stuff is very, very simplistic stuff, and I'd hesitate to call that AI. On the other end of the spectrum, speech recognition is really complicated and really hard, and you'll be pleased to know we don't cover that in this module. So that's kind of one side of natural language processing, and really is what natural language processing kind of used to be about, almost exclusively. But in more recent times, there's a whole different side to natural language processing that has evolved, and that's trying to use computers to learn how we form our language in such a way that they can help us to automate information extraction from free text. So much in the same way as machine learning, we kind of using a computer to try and learn how we make decisions in order that we can automate that process and even find things that we wouldn't maybe have picked up on. It's basically the same thing for natural language processing. We can get computers to learn how we form our language, how our language works, so that when we're presented with free text data that's unstructured text, we can kind of automate that information extraction. And in this course, that's what we're going to be focusing on, that aspect. So when we talk about natural language processing in this course, that's what we mean. And I think that's where the real benefit of natural language processing comes in for the sectors that you're all working in, and for the kind of projects that you're likely going to be doing. And natural language processing, as you're going to see hopefully, is a really useful tool that can be used to extract information from your data. In fact, I think most of the projects last year had some form of natural language processing in them, in either trying to extract. Sometimes they were based solely around it. So Mike Hill's excellent policing project that looked at Twitter sentiment analysis, obviously that was built entirely around natural language processing. But there were other projects that basically tried to extract information from free text data in order to as kind of part of that project. So you may well find that even if you're not doing a project that is exclusively about natural language processing, I've sort of a couple of great ideas already that are built around that, you may find that you may want to use aspects of natural language processing in order to enhance the data that you're plugging into your model or whatever it may be. Okay, so let's talk a little bit more. Let's drill down a little bit on what we mean by sort of automating information extraction from unstructured text. So there's a number of ways in which we can try and automatically extract information from free or unstructured text. And it's certainly not limited to the three that I've got listed here, but these are the three that we will cover in the course. And so I'm sort of flagging these off because I think these are probably the three that are most likely to be useful to you. So the first is something called named entity recognition. And that's all about, which I'll talk about in a bit more detail in a moment, trying to extract named entities, which are things like people, places, organizations, from unstructured text and categorizing them. So automatically pulling out from your unstructured text this data that we can then categorize. And that can be really useful in if you've got lots of unstructured text and you need to pull out certain pieces of information. There's also something called sentiment analysis. So sentiment analysis is basically all about identifying whether a piece of text is positive, negative, or maybe even neutral in tone. So what's the tone of the author? What was their sort of sentiment, their intent? And that can be really useful, as Mike demonstrated last year in terms of identifying what people might be saying about you and identifying positive things and negative things, etc. And it can also work alongside this wonderful thing called sarcasm analysis, where you try to basically identify if people are sarcastic. We'll talk a little bit more about that later. And then there's this third thing called relation extraction, which is basically where you're trying to identify the relationships between entities in text, and we try and automate that, and we basically put them into things called relational tuples, and you're basically trying to identify these two things are related in this way, and automating that process. And we will have a session on relation extraction once I write it in phase 2. So that's one of the ones that we've pushed back. You might find that useful. You might find aspects of it useful, but particularly in terms of thinking about your project design, probably the first two, which obviously we're going to be covering in this phase, are going to be the most useful for you. So let's consider an example. Let's imagine we work in a hospital, and the hospital's asked patients to fill out a survey about their experiences in the hospital. So a very common thing that is done. Now, if the survey will contain free text comments, which is likely to, then what we may want to do is we might want to identify automatically whether or not the comments that people have written are positive or negative, or maybe even neutral. So that would be the sentiment analysis bit. We might want to identify specific things that they talked about positively, negatively, or neutrally, and that would be the named entity recognition side of things. So, I mean, you know, particularly if you, it's usually more than just knowing how many people said you were great and how many people said you weren't. If you want to do something about it and you want to use that feedback, you probably want to know what they're talking about positively and what they're talking about negatively, and that gives you information that you can act on. And we might also want to identify the relationships between adjectives and the things they describe to understand how people describe their experience of various elements of a service, for example, and we could use relation extraction to do that. So let's start with named entity recognition. With both named entity recognition and sentiment analysis, obviously we've got the upcoming sessions where we'll show you how to do this in Python. And named entity recognition is actually really easy. But named entity recognition is basically where we're looking for named entities, which are real world objects that can be denoted with a proper name. Now, the entity may have physical existence. So Dan Chalk is a named entity. I physically exist, or at least I think I do. The University of Exeter is a named entity with physical existence, or it might be something with an abstract existence. So discrete event simulation and woodwork are examples of named entities that don't have a physical existence, but have an abstract existence. But they are real world things that can be identified with a proper name. And what's really useful when we come to do named entity recognition is actually not just extracting the named entities, but identifying the different types and categorizing named entities according to different types so that we can focus down on different aspects. And there are lots of potential categories that we can put our named entities into. Now, the specific categories will differ depending on the package that you're using in order to extract the named entities. These are the named entity categories, the default named entity categories for Spacy. And Spacy is the Python package that we're going to be using in this course. It's probably one of the most widely used natural language processing packages in existence now, and is very well regarded. And Spacy basically has its own set of categories, and you can add your own as well. So you can create others, although there are issues with that, as we'll talk about in the named entity session. But the default categories, we've got things like, so there's the category person, which basically is for people, including fictional people. So any named entities that are people come under the person category. We've got NORP, which stands for nationalities or religious or political groups. We've got FAC, which stands for facilities, things like buildings, airports, bridges, that kind of thing. We've got org, which stands for organizations, so things like companies and institutions. We've got GPE, which are geopolitical entities. So these are things like countries and cities and counties, that kind of thing. They're all named entities as well. We've got LOC, which stands for non-geopolitical entity locations. So things that are locations that don't fall into this GPE category would come under LOC. So things like mountain ranges, lakes, etc., would be considered under that category. Products, so things like objects, vehicles, foods, etc., but not services, they're separate. Events, so things like named storms, battles, wars, sporting events. Works of art, so titles of books, songs, films, etc. Laws, named documents made into law. Languages, any named language. And then we get, so all of that you can probably get on board with and think about those as, yeah, I can understand named entities. Then we get onto the slightly weird stuff that you may not immediately consider to be named entities, but they absolutely are. And this can kind of throw you off a little bit when you first do some named entity recognition. So there's also these categories down here. So date, any absolute or relative date or period would be considered a named entity. So the 3rd of March 2021 would be considered a named entity. 3 months from June the 1st would be considered a named entity. As would times. So times that are smaller than a day would be considered named entities as well. Percentages, anything where you've got the including the percentage character would be considered a named entity. Money, so any monetary values, including the unit of money, so £2.50, that would be considered a named entity. Quantity, which are things like measurements such as weight or distance. And then ordinal, which is words like first, second, etc. And cardinal, which are numbers that don't fall under one of these other types up here. And as I say, you may not immediately think of these as named entities. And the other thing to say is that you probably, depending on what you're doing with your named entity recognition, you probably are not interested in these things. You might be, depending on what you're doing, but you're probably not. But that's part of the reason why we categorize these things, and so that we can say, okay, well, I'm not interested in dates and times and all this stuff, so I can ignore all that. So any named entities that get picked up that fall into these categories, I can tell it to ignore. And so that's really useful that we can categorize it in that way, and that's why we do it. And you may, in fact, depending on what you're doing for your analysis, you may only be interested in 1 or 2 of these categories. And just focusing in on, for example, you may want to find out in a piece of free text what people are mentioned, and so you may just want to zoom in on any named entities that are categorized as person. So it depends what you want to do, because as you can see, you're rarely going to want, I mean, there's a lot of named entities that are going to be picked up across the board, as you can see from these kind of very wide ranging categories, and you probably don't want to pick up everything every time you do this. Okay, so let's get you to practice a little warm-up exercise here. Practice our understanding of what a named entity is. I'm going to put you in your group for 15 minutes. What I want you to do, I'm going to give you a piece of text, which will be on the slides that you've downloaded as well. I want you to study the text, and I want you to identify all of the named entities in that text, and I want you to categorize them according to the spacey categories on this slide here. If you feel that none of the existing categories adequately categorizes a particular named entity, then you are welcome to create and name your own category if you would so prefer. So find all the named entities as a group, and then categorize them, and categorize them according to these ones, or create your own as well. Okay, so here's the text that I'm going to give you. Yesterday, Derek went to Waitrose and purchased a loaf of bread and a pint of milk. It cost him a total of £1.30, which he thought was quite reasonable. When he was in France a few weeks ago, he felt that bread was priced a little too high. He's often wondered if he should learn a bit about bread making, but he'd have to learn the basics of cookery first. Okay, so I'm going to open up your breakout rooms, have a go as a group just for 15 minutes. So we'll come back at 10:05, and identify the named entities and their corresponding categories. Okay, have fun. Okay, hi everyone. So hopefully you had a good stab at that. Managed to get around a couple of groups. Apologies, I completely forgot to turn on the screen sharing initially. That's now all enabled for the future activities that you're going to be doing. So what I'm going to do, I'm going to so as I was bouncing around a few of you, I noticed most of you falling into the same trap that people normally fall into with this, in that you've picked up far more stuff in there than is actually named entity. So what I'm going to do, I'm going to show you what I think the named entities are. I do think I've missed one, so thank you to the 2 groups that I saw that picked up on it. So I do think there's one that's missing, but I think some of the things you've picked up are not named entities. So let me show you what I think, and then I'll ask you to chip in where you think I've missed things. So let me share my screen. Okay, so this is what I picked up here. So yesterday is a date. That's a named entity there. Derek, obviously that's an easy one. That's a person. Waitrose I picked up as an organization. Loaf is a quantity of the bread, which is a product. Pint is a quantity, and milk is the product. So again, we've got this quantity product relationship a couple of times there. We've got some money mentioned, £1.30. France is a geopolitical entity. This is a country. A few weeks ago is a specific period of time, so we can categorize that as a date. Then we've got bread again as a product, and then bread making and cookery I've listed as works of art. Now you may have set up a separate category for that, but I think that's how I would typically categorize stuff like that. There's a little bit more sort of abstract in terms of things, but you may have come up with your own category, and there's no right answer. And indeed, you'll see that you can actually train it to pick up those things however you like. Now, the one I think I've missed is the first at the end here, which should have also been picked up as a named entity as well. So apologies, I did miss that one. However, I don't think I've missed any others. So would anybody like to chip in if they picked up stuff that they think should be included?
We said Waitrose was a facility and an organisation.
Yeah, well, it would either need to be one or the other.
Okay.
But I think it would fall into organisation because it's a named organisation as opposed to, so a facility would be things like sort of airports and things. But you could, as I say, you can train it either way, and it's a bit of an art form. But it would have to be one or the other. You can't have both. Anybody else?
Oh, sorry.
Oh, the price of bread in France, if that would be something.
So again, sorry, did you say the price of bread?
Yeah, so he felt that bread was priced a little too high. Would the price of bread be a named entity?
No, because that's so what you're looking for is it has to be something that has if it doesn't fall into one of these sort of numerical categories or date time categories, it has to be something that has a proper name associated with it. So no, that wouldn't. So bread is a named thing, but the being priced a little too high is just the relationship to that. We'll see in a minute as we come on to some of this stuff how some of this stuff links together. But yeah, that wouldn't be. Anybody else?
But he.
No, because again, that would be so although that relates to Derek, it would not be classified as a named entity because he is not named there. So Derek would be, but he would not.
I'm just wondering about whether a loaf and a pint are important as opposed to just the words themselves, as to distinguish them from half a loaf and half a pint.
Yeah, that's a good point. Yeah, you may be interesting to see how that would be picked up with a named entity recognition. Actually, you're probably right. Actually, because we're colloquially saying a loaf, and what we're actually meaning is one loaf of bread and one pint of milk. But obviously, we wouldn't say that. But that's kind of what we mean. So yeah, I would probably agree. It probably should strictly be a loaf. I don't know whether it'd be interesting. I should feed this through Spacey and see what it picks up. Yeah, we had a raised hand. Oh, sorry.
There's one other thing I thought. What about the basics of cookery? Isn't the basics an abstract term?
No, because that's as we'll come to see in a minute. It's basically modifying this named entity. Okay. So this is the named entity, and the thing we're describing about it is the basics of it. This is where it gets fun. But we'll see a little bit of that in a moment. Yeah, had a couple other raised hands. Anybody else? Sorry. No. Okay. Great. It's a bit, as I say, it's a bit of a work of art, and it can be a bit weird picking out what is a named entity and what isn't. The good thing about the good news here is that the package we're going to show you does this for you, and it's very good at doing it for you. But it's important that you understand how it's doing it, and how it's categorizing and how it learns and you know what it's doing sort of under the bonnet, particularly because you may want to train it to pick up other stuff. Yeah, I mean it will take out a lot of the hard work for you in terms of doing this, so you don't have to, you know, we're going to talk a lot about grammar this morning, and you don't have to worry too much about that, other than having a sort of reasonable understanding of what it's doing underneath. But this will all make sense a bit more as we go on. But if we think about it, if we took that as a slice of text, the key things that we want to pick out are these things. And probably we're not interested in some of this. So, you know, if we wanted to pick out, probably if we were doing some analysis on this fascinating story about Derek going to Waitrose, it's probably things like Derek, Waitrose, milk and bread. And that's probably going to be the stuff that we'd likely want to pull out. So, and we can identify actually it's the, you know, maybe it's the persons and products that we want to pull out of this particular analysis. Okay, let's plow on. Can everybody just make sure they're muted again, just in case you get any feedback as well. And let's move on. So we've talked about noun phrases. Sorry, no, we haven't. We've talked about named entities. What we're leading up to is trying to get a computer to recognize automatically and find these named entities. So what we need to do that, as we talked about right at the very start of this course, when we need computers to do anything, we need to give them some rules to follow. And so we need to give the computer some rules to explain how and where to find named entities. Now, because named entities are all things, to find named entities, we need to look for noun phrases. So noun phrases are basically phrases that are either headed by a noun or an indefinite pronoun, which I'll talk a bit more about in a moment, or perform the same grammatical function as a noun. Now that probably it sounds like hell to most of you, so let's just put that a slightly simpler way. So basically a noun phrase includes a noun, for example cat, and the modifiers which identify it. So my cat would be a noun phrase, John's cat would be a noun phrase, the cat with white stripes would be a noun phrase, the cat who ate all the tuna would be a noun phrase. Most of these do describe my cat. So it's the noun, you've got a head noun or something that stands in place of the noun, but in this case we've got the noun cat, and then all of the things that modify to identify that specific cat. So in this case, whose cat is it? It's my cat. Whose cat? It's John's cat. Which cat is it? It's the cat with white stripes. Which cat? It's the cat who ate all the tuna. Okay, so you've got the head noun, and then the modifiers that identify that particular head noun. I'm sure you're already bowled over with the amount of fun this is. So let's plow on through this fun by looking at some examples. So here's some examples of some sentences along with the noun phrases within those sentences. In each case, I've underlined the noun phrases and the head noun is in bold. So the sentence, the staff were very helpful, but the food was terrible, contains two noun phrases, the first being the staff and the second being the food. Okay, so in each case, here staff is the head noun and the modifies it, identifies the staff, identifies the instance of staff we're talking about, and the same with food. A green-eyed Tom enviously watched Dan's amazing lecture. So again, we've got two noun phrases here. We've got a green-eyed Tom. So Tom is the head noun, and he is green-eyed. So that describes which Tom we're talking about. And here we've got lecture as the head noun. And which lecture is it? Well, it's Dan's amazing one. Probably doesn't identify it too specifically though. And then in this third sentence, we've got three noun phrases. We've got many universities, academics consume vast quantities of cake, which is absolutely true. So we've got three noun phrases here. The first one, at many universities. So universities is the head noun, and at many modifies that that noun so that we refer to which universities we're talking about. Oh, we're talking about at many of them. Academics is a noun phrase, even though it just contains the noun, because you can have a noun phrase without any modifiers. And vast quantities of cake is also a noun phrase, where cake is the head noun, and how much cake are we talking about? Well, we're talking about vast quantities of it. Okay, so it's the noun, the head noun of the center of the phrase, along with the words that modify that noun, so that you identify which noun it refers to. Okay, so over to you again. I've given you 6 sentences, and I'll give you 10 minutes in your groups to go through and identify the noun phrases in these sentences, along with the head nouns within each noun phrase. You can only have a single head noun in a noun phrase. So you may want to do the same as I did, although you can use whatever system you like. Just underline the noun phrases in these sentences, and maybe put in bold the head noun. Okay, so I'll put you in your groups. You've got 10 minutes. Screen sharing should be enabled now. That should make it a little bit easier for you. So we will resume at 12:30.
Okay.
Hi everyone. Okay, welcome back. So if you had a good go at that as well. Again, I'm gonna show you the solutions. If anybody wants to sort of shout out anything different they had, we can discuss that. So let me just bring up my screen. Where are we? Here we are. No, not that one. Okay, so here are the 6 sentences, and here is how I identify the noun phrases. So 2 men walked into their local bar and thought their situation sounded like the start of a joke. So I've picked up 4 noun phrases here. I've got 2 men. So men is the head noun, and 2 modifies it. So 2 men is the noun phrase. Then we've got their local bar, bar being the head noun. Which bar is it? It's their local one. Their situation, situation being the head noun, and which situation, it's their situation. And the start of a joke, with joke being the head noun, and we're referring to the start of it. Second one, many students felt the dance tutorial was the best, but then again, people are often wrong. We've got 3 here. Many students, students being the head noun, many modifying that. Dan's tutorial, so tutorial is the head noun there, and which tutorial is it? It's Dan's. And then we've got this standalone one of people here, which is a noun, so therefore it qualifies as being a noun phrase, but there's nothing modifying it. We're just referring to people. Then we've got this 3rd sentence here. Most people tend to use Windows, but increasingly people are turning to Linux as it's a much better operating system. So we've got 4 noun phrases here. Most people, so people is the head noun, and we're referring to most people. Windows and Linux are both separate noun phrases. They're both nouns, but they are not modified in any way in this sentence. And then we've got a much better operating system being the head noun, the head thing we're referring to, and we're saying it is a much better operating system. That modifies it. 4th one, suet can be used to make many different traditional dishes. Again, suet being a standalone noun phrase. And here we've got dishes as the head noun, with many different traditional describing the dishes. Then in this 5th one, so this might have thrown you off a little bit. So we've got 4 noun phrases again here. I think my black cat thinks I'm rather dull, as he often yawns when I'm talking about my daily routine. I'll start with the easy ones first. So my black cat, so cat being the head noun, and it's my black cat. And my daily routine, so routine is the head noun, and it's my daily routine. What you may not have picked up on is that I also comes as a noun, or more specifically a pronoun, and a pronoun stands in for a noun. So remember, a noun phrase doesn't have to include a noun. It can include something which can stand in for a noun, and that's the definition of what a pronoun is. And so I would stand in here. Here, I'm not sure how Spacey would. I think Spacey would return I'm. But I'm not 100% sure on that, because obviously if we were writing this out, we were actually saying I am, in which case I would be identified separately, but I've got a feeling Spacey will return I'm, but I'm not 100% on that. And then the last one, the above sentences show the random stream of rubbish that enters my head at any one time. So the first noun phrase being the above sentences, sentences being the head noun, and we're referring to the above sentences. And this one, which I think quite a few of you had separate noun phrases here, but actually what we've got here is a single noun, rubbish. And then all of this is modifying that head noun. So which rubbish are we talking about? It's the random stream of rubbish. Moreover, the rubbish that enters my head at any one time. All of that is describing that head noun. And that's why it's important to understand the concept of a head noun, because there are multiple nouns like head, for example, here, stream, but it's you have a single head noun. It's the thing that you are most talking about. It's the focus of that part of the phrase, and then everything else is the stuff that's modifying the stuff you're talking about in that head noun. So here it's rubbish, and all of this describes that head noun. Did anyone else have anything different on this?
Dan, I'm just a bit confused why the second I'm isn't in number 5. Why is one of the I's in I'm listed as a noun phrase, but the other's not?
Very good reason for that. I missed it. So thank you for pointing that out. I'll just quietly correct that now and pretend that it was there all the time. Thank you.
And also the he as well in that sentence. Does that not count? Because that's another pronoun.
It does indeed. So thank you very much for also pointing that out. I think what we're nicely demonstrating here, by the way, and kind of the point of these exercises is A, to get you to understand what's going on underneath, and B, to show you why having AI that does this for you is actually really useful, because it's a blooming nightmare. Anybody else? Anything else I've probably missed?
Would the second people in 3 be the same? Is that not a noun?
Increasingly people. Oh yes, you're right. Goodness me, there's a lot more here than I thought. Yep, thank you. I'm now frantically reading through this, see if I've missed any others. I'm wondering if this actually should be as well, because best is being used as a noun here. I think that should be. God, this is a nightmare, isn't it? Let's put that in. So I think that should be as well, because where you've got stuff that best, it's the best. It's being used as in the context of being a noun. Okay, I think that's all of them. Unless anybody else can find anything. This has been a good learning experience for me as well. Okay, so that hopefully that's given you a bit of a indication though of what we mean by noun phrases. You basically got a head noun or something which stands in for a noun, which are the ones that are usually harder to spot, and the things that modify that particular noun. So let's go back to the slides. Okay, so let's keep going with grammar. We can see how much fun I had. So much fun there correcting that and realizing all my mistakes. That was just so much fun. So let's talk about types of noun phrases. So first of all, let's start with definite noun phrases. So a definite noun phrase is one where the head noun, which you've just had some practice at picking out, clearly refers to something specific. So that might be something that's either been previously mentioned in the text, or which is previously known, or which is something unique, or which is something which is being identified by the speaker. And the head noun in a definite noun phrase will be prefaced by the definite article, which is the word the, unless the specificity, the thing that makes this something specific, is contained in the noun itself, such as with an ordinal number, e.g. first, second, or there's something that you don't require the definite article because the thing that makes it specific is already captured in the noun itself. Now, the definite article also may be potentially followed by adjectives, which will describe that noun, and we'll come back to that in a moment, but you can't wait. So that's a very complex way of saying these are the sorts of things that constitute definite noun phrases. So I ran over to the dog. I sat next to the very fluffy cat. In both of these cases, both examples of definite noun phrases, because we're talking about very specific examples of the head noun. So dog here being the head noun, and it's prefaced by the, so it's very specifically, we're talking about the dog. We're not saying a dog, we're talking about the dog. The very fluffy cat would be a noun, a definite noun phrase, because cat would be the head noun, and it's the very fluffy cat that we're talking about very specifically, the very fluffy cat. Okay. As you might imagine, as well as definite noun phrases, there are indefinite noun phrases, and that's one basically where the head noun refers to a singular noun, where the reader or listener does not know to which specific one we are referring. The head noun is often prefaced by the indefinite article, so that's a or an, again, potentially followed by some adjectives as well. There are other complications, though, around indefinite noun phrases. I was going to include some tutorial about that. I think it's best you don't go down that rabbit hole. So don't worry about it. Okay, for now, just it's things that are head nouns where it is not clear to which one you are referring. Okay, so to take our examples from before, these would be indefinite noun phrases. So a dog would be an indefinite noun phrase. Head noun is dog, and we don't know which dog. We just ran over to a dog. A very fluffy cat would be an indefinite noun phrase, because we don't know which very fluffy cat we're talking about, and there are many. Okay, so that's the key difference. In the first, with definite noun phrases, you're talking about it's very clear to the reader or the listener which example of that noun, which specific noun you are talking about, and with an indefinite noun phrase, it isn't. Basically, it's unclear which specific instance, to use object-oriented terminology, you are referring to. So, if you're sat there thinking, why should you care? This is pointless. Obviously, other than the fact it's so much fun. It's because named entities are found in, can anyone guess? Okay, I'll tell you. It's the definite noun phrases. So all that stuff I said, don't go down the rabbit hole of indefinite noun phrases. Definitely don't go down it. You don't need to worry about them for this stuff. So what we need to do, if we're going to be looking for named entities, is we need to find, we know that named entities will be found in noun phrases. That doesn't mean that all noun phrases will contain named entities, but all named entities will be contained in noun phrases. And moreover, we now know that named entities will be found in definite noun phrases, not in indefinite noun phrases, because remember when we talked about named entities, we said they are specific named things with proper names. They refer to something very specific, so that we can't therefore find them in indefinite noun phrases, because a cat can't be a named entity, because it doesn't have a proper name and we don't know which one it's referring to. So we know that named entities are found in definite noun phrases. And we also know that definite noun phrases will often have a head noun prefaced by the word the definite article, unless they contain the specificity within themselves, like things like ordinal numbers. So in theory, it should be easy to identify the ones that are prefaced by the definite article automatically. We can just look for text that starts with the, can't we? No, we can't. Unfortunately, it's not that simple. And there are two key problems with doing that. The first is, as you probably already worked out, we don't just usually refer to nouns by themselves. We may have things like adjectives that are getting in the way. So we might say the cat, or we might say the fluffy cat, and we'd need to pick up both examples. The second problem is that we need to identify what the head noun is within a noun phrase, and there may be more than one contender. So here are a couple of examples. The vicar, Brian, has 2 contenders for what is the head noun here. My cat, Bob, has 2 contenders. And so if we're going to try and get a computer to automatically pull these things in, we need to come up with some very clear rules about what the head noun should be when it's faced with multiple options. And we saw a little bit of an example in the last exercise where we had a noun phrase where there were a number of nouns within that noun phrase. And now we could pick up that rubbish was the head noun, but we need to find the rules that will then tell a computer to do that. But let's worry about the first problem initially. So, the fact we may have adjectives and stuff in the way. So to do that, we need to understand a bit more about grammar, unfortunately. And something about parsing and about a concept known as regular expressions. So let's start with a bit of grammar. Probably looking at this slide thinking, oh no. So parts of speech, or POS, to give it its abbreviation, refers to basically the categories that we assign to words that describe their syntactic functions. Or to put it another way, here are the things that we all learned about in school and then most of us immediately forgot. So parts of speech, there are, in the English language, there are 9 parts of speech, which are as follows, and each of these describe the syntactic function of a word. And of course, the same word can have different parts of speech classifications depending on how it's used. So I just a moment ago said about the word best, which is being used as a noun, but of course it may be an adjective. It probably is in most cases. So these are the 9 parts of speech. Just to remind us, I'm sure we all remember this very well, but let's just remind ourselves anyway. So we've got nouns, they're the easy ones. So they're the names of things, persons, places, ideas, that sort of thing. Pronouns are step in for nouns. They're used in place of a noun. So me, he, she, I, etc. These are all things that we use in place of a noun, so we're not constantly repeating the noun, and they can stand in. Verb. So verbs being actions or expressing some state of being. Adjectives being describing words for things, so it in some way modifies a noun or a pronoun, so describes that noun or describes that pronoun, which remember is just standing in for a noun anyway. Adverbs, which are like adjectives but for verbs, so they're describing and modifying verbs in some way. These are probably the ones that people tend to remember a bit more, but then we've got these sort of more obscure ones that people tend to forget a little more, certainly I do. So we've got things called determiners. So determiners limit or determine a noun. So where we say things like 2 dogs or the rabbit, it's where we determine the kind of quantity or limit the number of that noun. We've got prepositions. So prepositions govern a noun or a pronoun to express a relation with another word or element in the clause. So these are basically words like by and to and at. It joins up those things that expresses some sort of relationship between nouns and other nouns or other parts of a sentence, or part of a sentence, the clause. Then we've got conjunctions. These are the sort of joining bits, so they join words, phrases, and clauses together. So words like and but and when, those kind of joining up words. And then we've got my favorite, interjections, which are words used to express emotion. So things like hey is an interjection. So they're the 9 parts of speech that we have within the English language, and within any piece of text, we should be able to identify what parts of speech category each word falls into. And again, that same word may play different syntactic roles depending on the context of that particular sentence. And the labeling of words according to their POS category is known in natural language processing as POS tagging, and it's something that you will do very often. Unfortunately, you don't have to do it manually. There are very good pos taggers out there that do this for you. But as you can see, it's not a trivial thing, because we have, all sorts of complications in terms of the English language, in terms of, words being used that may be a noun or maybe a verb or maybe an adjective, depending on how it's used in the context of a particular clause or a sentence. So you probably saw this coming. So I want you to pos tag the following paragraph. I'm going to give you 20 minutes and take 5 minutes to stretch your legs as well. So we resume about 1:15. I want you to pos tag this paragraph. The grey horse in the field was slowly eating some grass when she looked up and saw a bird fly onto the fence. The bird was then joined by 400 more birds. Wow. Clearly the author had been watching too much Alfred Hitchcock. So you need to identify the pos tag for each and every word in that paragraph. Have a go at that, and then stretch your legs and don't think about grammar for a little bit. And we'll resume at 1:15. Okay, I'll stop sharing and open up the rooms. Hi everyone. Okay, welcome back. Hopefully you had a bit of a chance to have a bit of a break there too, which you probably need after doing some grammar. I know it's horrible. The good news is, as I mentioned earlier, you don't need to worry too much about this stuff, because there are very good packages that you will be using that will do this stuff for you, but you still need to work with things like pos tags and noun phrases, and so you need to have a sort of basic understanding of how what they are and how they work, and so this is really just to get you used to seeing pos tags and the different pos tags and things like that. So if don't let this put you off doing natural language processing, because you don't have to manually do this stuff, but you do need to understand enough to kind of work with it and work with the outputs. So I'm just gonna share the solution with you for this. I took an extra couple minutes because part of the solution I remember was a bit weird on this one, and so I had to go back and watch the bit of my video from last year where I explained why it's weird. And now I've now remembered. So I'm going to give you, if you didn't get this, that's absolutely fine, because I remember having to look this up, and there was a whole debate that I found about this particular pos tag. But let's show you. So let me share my screen. Okay, let's look at the solution. Okay, so some of these were fairly straightforward. So the being a determiner, grey an adjective, horse being a noun. In is a preposition because it links the horse to the field. The is a determiner for field, which is a noun. Was is a verb. Slowly is an adverb because it modifies the verb eating. Some is a determiner because it limits the noun of grass. So we're describing how much grass. It's some grass, which is a noun. When is a conjunction because it links the two clauses of the sentence together. She is a pronoun, stands in place of the noun horse. You could have said when the horse, but we don't, we just say she. Looked, which is a verb. Op, which is an adverb because it modifies the verb looked. And is another conjunction, again linking parts of a sentence together. Saw being a verb. A is a determiner for bird, which is a noun. Fly, which is a verb. Onto, which is an adverb. The, which is a determiner. Fence, which is a noun. The determiner, bird, noun. Was, verb. Then, adverb. Joined, verb. By, so just to explain that one a little bit, so adverb then is modifying, in this context it's saying then joined. So when was it joined? It was then joined. So it here then plays the role of an adverb for the verb joined. By preposition. 400, which is a determiner. More, determiner. So together those form a determiner. But they are separately determiners as well. Birds, which is a noun. Wow, that's an easy one. Interjection. Clearly, adverb. The determiner. Author, noun. Had, verb. Been, verb. Watching, verb. Now this is where it gets a bit. So let's go on to Alfred Hitchcock, which I'm sure you all picked up. That was a noun. This is where it gets a bit messy. Too much is the issue, and this is what I had to remind myself of, because I remember looking this up quite extensively. So some of you may have put that too much is an adverb because it modifies watching, which is a verb. And as far as I'm concerned, I think that's okay. And I'd fully support you on doing that. However, strictly speaking, the official pos tag is supposed to, for these words, is supposed to be that too is an adverb and much is an adjective. And if I'll try and explain this, given I've just watched myself try and explain it last year. So much actually plays the role of an adjective for Alfred Hitchcock. So that plays the role of an adjective, the word much. And because we've got a word that is then essentially modifying that adjective, it then plays so to then plays the role of an adverb because it modifies the word much, which is playing the role of an adjective. Don't worry about trying to get your head around that too much. It's a bit weird. The fact that there were debates about what that should be when I looked online, I wish I hadn't. There's a lot of rabbit holes that you can end up falling down with pos tagging and grammar in general. But officially, that should be to as an adverb and much as an adjective. But if you've put that as an adverb, as far as I'm concerned, that would be good enough. But yeah, this just gives you don't worry about the details too much, but it gives you a bit of a sense about what pos tags are, how they work, what the different ones relate to, and the fact that you can have words that would normally be other kinds of pos tags, but depending on the context, remember the pos tag describes their syntactic role. So a word does not have a singular, in most cases, a singular pos tag. The pos tag only comes into play when it's used in the context of some text in a sentence. And then we describe the syntactic role that word is playing using the pos tag. And that's the key thing to take away from this. Okay, let's move on, because I think we've done enough worrying about that kind of stuff. Okay, let's talk about parsing. Parsing is a very important process within natural language processing. And you'll hear parsing talked about a lot within NLP. So parsing is basically the process in which we break down a sentence into its component parts and we describe the syntactic roles of each component. So the process of parsing would allow us to identify the noun phrases in some text. And we could also use parsing to identify the pos tags, as we've just done. So those things that you've just manually done, what you were doing was parsing. Okay, in both cases, you were identifying the syntactic structure of the text and breaking it down and saying this is a in the case of noun phrases, these are phrases where you have a head noun and it's being modified in this way. And in the case of the pos tags, you're identifying for each word in the context of this text that the role of this word is playing this syntactic role within this document. And we commonly use things called regular expressions to help us in the parsing process. So regular expressions, which you may have come across before, well, you will have, but you may not be aware they are, sometimes abbreviated to regex, is a sequence of characters that define a search pattern. So they're used extensively in things like search engines to define the rules for the pattern of text that you want to search for. Okay, so a regular expression will define a particular pattern that it needs of text that it's trying to look for, and we can use, when we're parsing, we can use regular expressions to specify certain rules for identifying particular syntactic structures that we're interested in. Now, regular expressions have a horrible syntax that is not particularly friendly, and once you get used to them, they're not too bad. But they have these kind of weird expressions that we use. Things like curly brackets will denote the start and end of regular expression. Then we put in these little arrows here, the sort of the label of the thing we're looking for. So that would mean match a word with a pos tag of VBD, which means a verb in the past tense. The question mark will say match this thing optionally, so it doesn't have to be there, but it could be. If we put the plus sign, it basically means match a sequence with at least one of these things, so one or more of whatever that is. A wildcard, the asterisk, will say match sequence that contains 0 or more, so there may be more than one, or there may be one, or there may be none. We can use the vertical bar here to say match X or Y, so match this thing or that thing. Full stop basically says match any character, and the brackets around something say treat that as a group. So you could imagine putting these kinds of things together to find definitive noun phrases, for example. So we could say use this regular expression to say, remember, a definitive noun phrase may just contain a noun on its own, so we'd need to get it to look for nouns on their own. So this regular expression would say look for, so the NN basically just means a noun, match a noun on its own. But of course, nouns may also not be on their own. They might have an adjective, but they may not. So we could use this regular expression, which JJ basically stands for adjective, and we could say look for nouns, but there may also be an adjective in front of them. Can anyone spot any problems with this approach?
A lot of it's highly contextual.
Yeah, that's certainly an issue. Any other thoughts?
There's like a typo or someone forgets to put something in.
Yes, that's a very good point. Well, let's talk about what some of these problems are. First one, I would say, is probably the biggest one. This is a complete pain in the bottom. It is horrendous to try and do this. It turns out, now there is an app that if I find the link to it again, I will share with you. Somebody developed this app as part of the Natural Language Toolkit, which is a really nice toolkit that's used in Python, that allows you to basically try and write your own regular expressions to pick up in some sort of sample text, gives you some test text, a bit like in the machine learning we saw about, having a training set and a test set, and you basically test out your rules. And what I spent the best part a couple of years ago, best part of an afternoon trying to go through this, and you just end up going around in circles, because you think, oh, okay, yes, I haven't accounted for the fact there might be an adverb here in between that, but then if I do that, I start picking up noun phrases that aren't noun phrases. So now how do I undo that to say that actually that isn't a noun phrase, but that is? It's an absolute nightmare to try and form potential combinations of pos tags that could form definite noun phrases, and so you'll end up writing rules that will pick up stuff that isn't a noun phrase, and you'll miss loads of other ones as well. So it's a nightmare. Now the good news is you don't need to do it this way anymore. For years this was how people had to do it in natural language processing, and it's probably why it didn't take off, because it's horrible. It's absolutely horrible having to try and do this. You still have to do a little bit of this sometimes when you're looking for certain structures. So when we come on to talk about next year, when we talk about relation extraction, we'll show you a little bit of regular expressions. Fortunately, Spacey has a really nice inbuilt regular expression type thing that is much friendlier to use, which helps. But sometimes you want to sort of pick up those kind of rules, but you don't have to do this extensively. And certainly for the kinds of stuff you're likely to be doing, you probably won't need to be worrying too much about that kind of stuff. But of course, the other big problem, as you just touched on, let's imagine, for example, that we are using some natural language processing, and we're going to look for named entities in notes made by paramedics at the scene of an incident. And let's imagine we're going to try and use some regular expressions to do that. Let's just take a moment to think, which do we think is a more realistic reflection of the kinds of notes you expect to see? So maybe the paramedic wrote, "It was morning and a slight chill was in the air. I arrived to find that Mrs. Smith had clearly taken an unpleasant fall and was in need of help. Quickly and without a moment's thought, I rushed to her and asked if she was in any pain. Now we could pos tag that and parse that particular paragraph of text quite easily. It's got a nice grammatical structure, and we'd be able to identify noun phrases very easily via some regular expressions there. It's probably not going to be as realistic as something like the second example. Arrived AM, Mrs. Smith had fallen, rapid assistance given, asked if she was in pain. Now, clearly, that's going to be a more likely example of the kind of text that you're going to be working with. And let's be frank, probably the kind of text that you're going to see in a lot of examples of the kind of data that you're going to be working with. Because it's very rare that in these kinds of situations, even situations where, you know, patients are filling out surveys, that we're all going to write in perfect grammar. But unfortunately, if we take the approach of using regular expressions, it necessarily assumes either that we are and that we're all writing in perfect grammar, or at the very least, we are writing consistently with each other. So we're writing consistently badly. Now, clearly, those assumptions are poor, and that's why these kind of approaches don't tend to work very well. So if the regular expression approach to try and find these definite noun phrases for identifying unnamed entities isn't ideal, because it's too difficult for starters, and it's too reliant on the text following consistent grammatical rules, then what can we do? Now, fortunately, there is an alternative, and its name is Spacey, which I mentioned before is a Python library, very widely used for natural language processing. And one of the many things that it does in terms of it being able to parse text is it includes an AI-based method for identifying named entities. Now, in the next natural language processing session of the module, we're going to show you how to do this, and you'll see it's actually really easy using Spacey. But I'm just going to give you a bit of an introduction here to how this actually works. So before the session, and I'll give you instructions ahead of the time, you will need to install Spacey, and there's other stuff you'll need to download as well. So look out for the instructions ahead of that session. But basically, installing Spacey is very easy. You pip install it in the same way you've installed anything else. So let's just talk a bit about how it works. So rather than using kind of the regular expression based approach, which is where you're trying to specify lots of rules for patterns of particular text and syntactic structures, that will identify things that are and aren't noun phrases, Spacey does things completely different. So what it does is it uses an AI-based approach. And what it tries to do is basically try and predict whether a given word or a given group of words is a named entity. And it does that based on the word itself and what the pos tag of that word is, and also the words that come before and after it. So it also takes into account, well, what are the words that come before it and what are the words after it? And it also looks at things like punctuation, etc. as well. And it does all this, and it uses this, collates all this together and uses them as clues, basically, to try and work out whether it thinks this is a named entity or not. So in much the same way that we talked in the machine learning session last week about getting a machine to kind of predict, given these set of inputs, what's the output, what's the predicted output. Here, we're using AI to do the same thing, but for words and for identifying named entities. So we're saying, given we see this word and it's got this pos tag, and these words that come before it and after it at various distances, and the pos tags of those words, I have learned as Spacey that this, I think there's a good chance this is a named entity. So it tries to predict it, and the way it does this is basically got lots of prior learning that's been done on corpuses, which are collections of written texts, where it's learned the kind of syntactic patterns it would expect to see when a named entity is present. So it's basically been trained on lots and lots of text, and the kind of text it's been trained on differs according to the model you use, and we'll talk more about that in the named entity session. But it's basically been trained to try and identify, okay, that's a named entity when you've got that kind of syntactic pattern. So rather than us trying to manually work out what all the rules are, which is really hard, we essentially get a machine to do it for us and to try and look for those hidden patterns. And it turns out it can do that very effectively. And that goes back to something we were talking about last week in the machine learning session, which was about sometimes the benefit of doing machine learning is to look for things that it's too difficult for us to see as humans. And trying to unpick the English language, it turns out, is really hard for us to do as humans. But we can get machines to try and look for those underlying patterns. It turns out they're very good at it. Certainly better than I am, anyway. Now, Spacey is using this approach, and it does something. It does this using something called a convolutional neural network. Now, I'm not going to go into detail about neural networks at this stage. I'm going to briefly mention what they are. I would strongly recommend you come along to the session 7D, deeper into machine learning, so the fourth session of the machine learning module, where we're going to talk in depth about neural networks and how they work and how you build your own neural networks. And also in the sentiment analysis session of this module, we will also be talking about neural networks, and you'll be building your own neural networks to determine sentiment of text. So at this stage, I'm just going to give you a very sort of basic understanding of what this does. Now, the convolution, there's different types of neural network. The convolutional bit, very often a convolutional neural network is used for things like image recognition or for text purposes. And just in simple terms for now, just think about a convolutional neural network is where you're basically taking a little window and you're moving that window across something, and then you're making decisions based on that particular window. So it's used in image recognition because you're looking at the particular pixels within that particular window of pixels that you're looking at, and then making decisions about, okay, I think this is the start of a face or whatever it may be. In text, you can imagine, given what we've said here, what it's essentially doing in Spacey is using it to say, okay, if I look at these 5 words, do I think there's a named entity here, given this is the central word and these are the words around it? Am I identifying anything that I think would constitute a named entity? So it's kind of sliding that little window across your text and making those decisions as it goes. So it's looking at a window of words each time. But what's a neural network? So again, I'm only going to explain it very briefly here. We're going to go into much more detail in the other sessions about neural networks. Neural networks are phenomenal things that were originally designed to try and work out how the brain works. Okay, and they're set up with that kind of structure. So they're set up as neurons, which are connected by synapses, with signals being sent along those synapses. So what that basically means is when you build a neural network, you have multiple layers of nodes which emulate the neurons in the brain, and all those nodes are connected to each other, and those connections emulate the synapses, synaptic connections in your brain. And you have inputs to and outputs from those nodes, which are sent as signals to the other nodes and weights associated with those signals. So basically, you've kind of got these series of nodes, and they're connected to each other in different layers. And so you've got over here, you've got your sort of input layers, and over here, you've got your output layer. And these things in the middle are called the hidden layers. Again, don't worry too much about this at this stage. We're going to talk much more about this in the relevant sessions. But basically what you're trying to do is say, you basically push through lots of numbers, and you say, this is the output I need. So in the case of named entity recognition, you might have a 1 indicating it is a named entity and a 0 that it's not. And what you're trying to do is get the machine to learn that when it sees this combination of input numbers, it needs to get to the value. If it is a named entity, it needs to get to the value 1 over here. And if it isn't a named entity, it needs to get to the value 0 over here. And it does this by all this stuff in the middle, which basically multiplies all of these input numbers coming in, and adds them all together, and it multiplies each of these connections that get multiplied by a weight, and it adjusts all these weights and all these numbers and all this stuff that it's doing in the middle to try and get from this set of numbers coming in to this set of numbers, the known output over here. And And it's really weird the way it works, but it's amazingly useful. And neural networks are hugely powerful tools that are widely used now. And as I say, we will talk more about them. But for now, just think about them as ways in which you have nodes that are have inputs to them and outputs from them. And these nodes are basically taking in inputs, they're multiplying and adding up these inputs in some way, and then spitting out the other side until eventually it gets to this output. So that it needs to get from this set of inputs to this known output and adjust itself so that when it sees these inputs, it can get to the correct output. Now you're probably thinking, well, hang on, we're talking about words, not numbers. In natural language processing, as with anything we do in computers, we need to convert everything ultimately down to numbers. And you'll see in the sentiment analysis session how we do that. So we can convert words into numbers. We give them a numerical representation, and then those numbers are passed through a neural network so that when it sees that pattern of numbers, which actually represent words, that it will get to that conclusion of, yes, it is a named entity, or no, it's not. And that's basically what it's doing. And because it's a convolutional neural network, it's doing that not on the whole text at once, it's doing it with this sliding window. So it's looking at, say, 5 words at a time, and then it slides over by 1 word. Now it looks at that group of 5 words, now it slides over, and it does that. And it's very, very effective at doing that. So don't worry too much about the details. As I say, we will go into neural networks in far more detail elsewhere in the course. But for now, just understand that's essentially what it's doing. It's turning the words into numbers. It's feeding them through a neural network, and it's training itself to try and get better at picking up patterns of words or numbers that essentially represent a named entity. And it does that based on being trained on huge corpuses of text. So it's been trained on lots and lots of text. And it's learned those kinds of hidden patterns that we struggle to see as humans, or at least struggle to communicate. It's learned those syntactic patterns, and it's very effective at being picking up what is a named entity and what isn't. So that's basically how it's working. Okay, so rather than us having to use things like regular expressions to try and specify all these rules up front, it's trying to learn those hidden patterns for us and uses that. And turns out it's much better, and it's also much friendlier than us sitting there scratching our heads. Okay, so let's talk a little bit about, we've talked a lot about named entity recognition. Let's just talk a little bit about sentiment analysis, because that leads on quite nicely from what we were just talking about. So sentiment analysis, again, uses these AI-based methods to try and automatically identify the sentiment or tone of a piece of text. And usually we're trying to work out whether it's positive or negative, and sometimes we also want to work out whether it's neutral. So in the same way we've just talked about with Spacey, where Spacey's trying to say, is this a named entity or not? And it's learned on lots of big corpuses of text that this is a named entity and that isn't, and it's learned those sort of hidden patterns. Here, we're doing the same, but we're predicting whether a piece of text is positive or negative or neutral. So again, we train it, we show it examples of this is text that is positive in tone, this is text that is negative in tone, and it learns via neural networks to pick up on the hidden kind of stuff in there, the hidden patterns of words, the hidden structures, the syntactic structures that tend to say this is people are talking positively here, or people are talking negatively. So the overall process for sentiment analysis is this, and we'll, as I say, in the sentiment analysis session, you'll go through this in detail. But basically, we have to load in the raw text data, the text that we want to determine whether it's positive or negative. We then have to clean the text up in some way, and particularly if it's anything that's come from the internet, for example, with the stuff that we have to do in terms of cleaning it all up, removing hypertext and things like that. But also for any text, we do stuff like changing everything to lowercase because we're not interested in where the capital letters are for sentiment analysis. We are for named entity recognition, but not for sentiment analysis. Removing punctuation, so we clean up the text in some way. Then we convert the cleaned text, the clean words, up into and we convert them into numbers, because remember, we have to feed through numbers in a neural network. We then convert it into a format, a shape that's usable by the neural network, which is something known as a tensor. Don't worry about tensors for the moment. As I say, we will come back to that when we talk about this in detail. Then we build up our neural network. We train the neural network on lots of examples, so much in the same way you did manually last week when you were trying to work out my film preferences. You basically do that within a neural network. You train it up, you gradually get better at identifying what the hidden rules are. And then once you've trained it up, you then use that trained neural network to predict new data. Okay, so what I want you to do, again, back in your groups, for the next 20 minutes, I want you to have a bit of a discussion about what you think some of the potential applications of sentiment analysis could be in your own organizations. You can think of potential problems that this could help with. And also what you think some of the challenges might be when you're trying to do sentiment analysis. I'll give you about 20 minutes. We'll come back just for 10 past 12. And then I'll ask a couple of groups just to share some of their thoughts, and then we'll talk about what some of those potential applications and challenges might be in the final section. Okay, so let me open the breakout rooms and go and have a chat about how some of this stuff could be useful. Hi everyone. Okay, so hopefully you've had a bit of a chance to have a chat about some potential ideas and potential challenges. I bounced around to a few of the groups and heard some really interesting ideas coming out of this. So I'm going to pick on a few groups just to share what they've been talking about. So hopefully you've got somebody that can just share some of that. So what we will do, of course, is to spin the wheel of names. So let's shuffle it off a bit and then spin it and see who will get first. Ooh, oh, I thought it was going to be Marvin then, but Skynet. So somebody from Skynet.
I think I jotted a few things down. We talked about social media analysis, surveys and questionnaires of patients or clients or service users. We talked about analysis of 999 calls, so whether the right team sent and what was the details that were given. And then we did a few for NHS. We sort of said friends and family and incidents and patient letters. For police, we talked about using the details of the reports that are sent. Sorry, I don't work in police, but the report that is sent, and then the eventual conviction, and see if the detail or the sentiment going in supported the outcome or helped it. And then with issues, we talked about particularly with subtext or like hypothesizing or writing about the future and things like might or will or could, and trying to interpret that into a sentiment. And then a lot of bias. So if you're using qualifiers, what's a baseline for good, bad, average? Who is the author? So maybe if depending on the behavioral or demographic details of the person who wrote the text, might have an inherent bias in it. That was unless anyone else wants to jump in.
Fantastic. No, that's great. Some great ideas there, and yeah, nicely picked up on some of the potential challenges there. I think bias is very important, and we'll talk a lot about bias in AI generally in the next machine learning session, I think it's next week, where we talk about ethics in AI, and a lot we'll talk in there about sort of bias and representation. So yeah, no, really good points. Fantastic. Thank you. Okay, let's spin the wheel again. See who we get now. I think it's going to be, Saint number 5, Johnny 5. Any volunteers?
Yeah, so we had quite a big talk about surveys in general, and actually whether we've come to design them these days just to make everything quantitative rather than qualitative. So whether they were the best places of finding out how people actually felt outside the boxes that we asked them to tick. So whether they could be redesigned and to find out a bit more. Then yeah, we had a discussion about places where we could get free text from either patients or clinicians, and the issues around them, such as spelling or how they write their notes, and whether the sentiment could be taken up from note making, or whether they would have to write in fuller sentences. We weren't sure about how intelligent the intelligence could be.
No, it's some really good points. That I mean, so just to take that last point, I mean that's so I mean that's the beauty of using an AI neural network kind of based approach, in that you can train it. So and we'll come to see some of this when we go into the sentiment analysis session. But there's something known as transfer learning. So basically, where you can start with a model that's been trained on sort of large corpuses of text that will be able to pick up on, so you have to retrain it on lots of common text that's used. And then you can use something called transfer learning, which is basically where you then add to the training by showing it examples that are specific to your particular area. So you get the added benefit of that additional learning, and then you can sort of pick up on any particular nuances in terms of the language that's used there. The advantage of doing it in using an AI-based method is that it's less dependent on the grammatical structure of stuff, and more to do with the kinds of words it's seeing, and the words that surround it, rather than this is an adjective followed by a noun followed by etc. So it can deal with that kind of messier text much better. We'll see that in the sentiment analysis session, where you'll get to try this out on the IMDb, the Internet Movie Database, and reviews. And people, don't write very grammatically well-formed reviews on there, but it can handle it actually very well. So yeah, this is the advantage of using that kind of method. Really good point as well, I think, about survey structure. I think you're right that surveys have increasingly been designed to focus in on particular areas, and there's many reasons for that, but I do wonder sometimes whether that's been done because it makes the analysis simpler, because you're wanting to find out about certain things, and that will then allow you just to focus in on that, but you do then miss other things that may be really important that people want to talk about, and so which historically obviously makes it very hard to then analyze. But if you can have something like this, where you can then use NLP tools to extract that information from free text efficiently, then obviously that opens up the door to allowing people to be more free in what they're saying and be able to still analyze that efficiently. I think that's one of the real key advantages of this approach. Thank you very much. Okay, let's spin again and hear from another group. Okay, I think it's going to be Holly. Yes, Holly. Okay, someone from Holly, please.
So we talked about some of the, we started talking about sentiment analysis, but then we ended up talking about some of the non-sentiment analysis, more NLP type things as well. But in terms of sentiment analysis, we talked about some of the difficulties in trying to get some of those notes from, let's say, patients, or from housing data or social care data, without something very clear to look out for. Having said that, if we're able to get some of that data, it'd be very interesting to see whether that influenced some decision making that took place, really. Is there anything else from the group from Holly that's wanted to add to my attempt at summarising this? No?
Great. Sorry, I was going to say, I think the other groups covered a lot of the same stuff.
Yeah.
We talked about the kind of issues about surveys and patient notes and things like that, and obviously using social media. I think, as C says, one of the things we thought is that there may well be IG issues around trying to get something, if you're trying to do something that's not got a very focused aim, but you're hoping to find something useful out, then there's challenges there in getting the data. But yeah, one particular example one of the group was talking about was for social health prescribing, and where yeah, you might get some interesting indication there of from looking at social media of how people were faring with that, and also whether possibly you could use it to look at whether there were if you had some internal data that wasn't very well structured on things like finding care home places, packages of care and things like that, whether it might possibly be useful for identifying where there's particular bottlenecks in a process there.
And
Yeah, no, I
think
think
staff surveys as well, isn't it?
Yeah, no, I think that's a really good ideas. I think, you know, anything where you've got, and I think there's an abundance of issues in, you know, it's not just the health service and policing and all sorts of sectors where you've got a lot of free text data, and actually being able to mine that efficiently and pick up on things like, you know, picking out things that people are talking about, or the way in which people are talking about them, or indeed a combination of the two very often can be really useful. So yeah, no, that's really good. Thank you very much. Some great ideas there, I think, that hopefully this session's kind of got you thinking a bit about how some of this stuff could be used. And it'd be great to see some natural language processing projects being proposed. As I say, I've already seen a couple of ideas which I think are really good, and how this stuff, we can actually use this stuff to enhance our understanding from some of this free text data. Okay, so just the very final bit before we close. So let's jot down some of the potential applications, potential challenges of sentiment analysis myself. So we touched on a lot of this. So automatically classifying service user survey data, and of course, you know, coupling that with things like named entity recognition. So you don't just find out, you know, whether people are talking positively or negatively, but find out what they're talking about positively or negatively, and giving you a chance to do something about that. And indeed, you know, Mike Hill's fantastic presentation from last year, his project work on Twitter did exactly that, and using that to try and enhance how they respond to their service users. So really good stuff that you can do with that. Analyzing reviews, you know, things like movies or books or whatever. Analyzing social media posts. So again, like Mike's project, being able to automatically identify stuff that you may be able to sort of act on proactively. And you can also use it for looking, you know, for positive or negative references to your organizations on websites and things like that. So we'll talk a little bit about one potential challenge. So you already, quite a few of you picked up on this idea of bias, which is really important, and we will be talking about that in the ethics and AI session. A really important issue that can be a real challenge depending on the kind of text you're working with in natural language processing, particularly for sentiment analysis, is sarcasm. So let's study these sentences. I loved having to wait for 5 hours to see a doctor. I was extremely impressed. I'd never seen a restaurant with more dirt per square inch. Well done. You managed to ignore every request for help. Quite an achievement. Now, I think as human beings, we could read those things, and probably most of us would consider those above sentences to be sarcastic. But there's an issue here, because there's positive language being used, and a machine may well identify these sentences as positive because positive language is being used. Indeed, if we think about it, really, if we as humans sometimes struggle to identify sarcasm, and particularly in written text, it's going to be very difficult to try and train a machine to be able to identify sarcasm itself too. So it is a real problem in terms of sentiment analysis. If we think about those particular sentences there, think about why you think they're sarcastic. What makes you think they're sarcastic, presuming you think they are? Why do you think those sentences are sarcastic? What is it about it what about them that is jumping out at you?
I think there are words that have very negative connotations that are sort of swamped by the positive words. So if you weighted the negative words more strongly, you might pick the negative sentiment out.
Yeah, that's a very good point. So you know, the fact there's
ignore.
Yeah, absolutely. So there's negativity in there, and maybe that's being weighted more strongly semantically in those sentences. Any other ideas?
I guess
Sorry. Go on, Jeff.
No, sorry, you go.
I was just going to say they're things that nobody would want. So nobody wants to wait for 5 hours. So they're like universal truths, I guess, or nobody wants that in food.
Yes, very much so. So if we think about sarcasm and think about how we try to detect, obviously subconsciously, when people are being sarcastic, very often it's to do with the fact that somebody is saying something that seems to contradict what we would believe to be true. So there's something known as sarcasm detection, and it's a branch of natural language processing that basically uses the same kind of AI methods that we've been talking about to learn when a piece of text is sarcastic and to try and identify that. And the way they try to do that is to compare, the best way theoretically to do this is to compare a statement with known truths. So exactly as you said, if somebody says, I loved having to wait for 5 hours to see a doctor, that's probably, that goes against what we would expect, because people don't tend to like to wait for services. And so that seems to be a contradiction with some sort of, as you say, universal known truth. Now, of course, it may not be. It might be somebody really did love having to wait for 5 hours to see the doctor because it allowed them to do X, Y, and Z, So it's really difficult to do this. And in fact, sarcasm detection is really hard. It's not trivial. And it's something that I probably wouldn't recommend that you go down the route of exploring. Mike did a little bit in his Twitter stuff last year that was really nice, looking at use of emojis and detecting whether somebody said something that was and then had an emoji or series of emojis usually that kind of contradicted the tone of what was being said, and he used that to try and identify where there might be likely sarcasm. So on Twitter, that's actually quite useful, because people will often say something and then use the emojis to kind of convey their actual emotion. So you could, the stuff that you can do there that was actually quite interesting. So you may find little bits like that depending on what you're doing, but in general, my general advice to you would be to consider how much sarcasm there is likely to be in your text. It's likely in most cases to be relatively trivial. If you're doing stuff around social media, you're probably going to get, it's more of an issue, certainly, I think. I would hope that in most cases, the kind of text you'll be analysing, you will get sarcasm, but I think it would be less sarcastic, generally speaking. And so you might want to take, a sample of your data and manually analyse whether you think there are issues of sarcasm, and if you're not really detecting much, then it's probably fairly safe to ignore that. So that, generally speaking, that would be my sort of recommended approach for this, because it is really difficult to do sarcasm analysis, but it's something that's worth knowing is there, and certainly you may come up with something like Mike did, that can be really interesting and worth exploring. Nonetheless, do check out this little link when you get the chance. The Sarcasm Detector. It's a great little website. Uses an AI-based algorithm in the background to try and work out if you're being sarcastic or not. And so you can put in sentences and it'll determine where you sit on the sarcasm scale. So it's quite an interesting little fun thing to check out.
It doesn't seem to be working.
Oh, does it not? Oh, I wonder if it's gone down. Oh, that's a shame. Okay, I'll check that out and see if it's moved or something. It's been there for years, so maybe that's gone, or maybe it's just temporarily down. But I'll have a look at that for you.
I just assumed you were being sarcastic with the link.
Me too.
That would have been great, actually. Yeah, let's pretend that's what it was. That sounds much cleverer. Fantastic. Okay, and there is actually another particular challenge as well as sarcasm when we come to look at sentiment, and that relates to what people are talking about in a particular piece of text, and that they may not just be talking about one particular thing, and they may have very different feelings about the different things that they are talking about. And that's something that we will cover more when we come into the sentiment analysis session, and we talk about something known as aspect level sentiment analysis, and I'll show you how ways in which you might want to approach that. Okay, but for today, that's all I'm going to be talking about. The idea of today was really just to give you a bit of an introduction to how natural language processing, specifically named entity recognition and sentiment analysis, how they sort of generally work in terms of the broad principles, but also just sort of hopefully fire off some ideas that you might have about how you could use some of this stuff, either positioning a project around this stuff, or it may be that you may want to incorporate aspects of named entity recognition and or sentiment analysis in some of your other projects as well. And so in the following sessions, in sessions 8B and 8C, you will see how to do this stuff. We'll show you how to use Spacey in the named entity recognition session, and how to do some stuff around word clouds and things like that. Some nice analytical visualizations in Python. And then in the sentiment analysis session, I'll get you to build your own neural networks that will actually be able to try and identify sentiment automatically within text. So hopefully that's of interest to you, and hopefully you'll join us for those sessions. Any questions before we close off? No? Great. Okay, in which case, just a reminder, so this afternoon session is pre-recorded. Do make sure you check out those geographic modeling videos. I see Tom's put on some follow-on videos as well. So if you've already watched them and you want to find out a bit more, there's some extra videos that you can watch, which go into a little bit more detail about some of the theory of this. So if geographic modeling is of interest from the first videos that you watched, I'd recommend checking those things out. Tomorrow you've got me again all day, so in the morning we've got our first option session, which will be for those of you wanting to learn more about SymPy. I'm going to show you how to do it in object-oriented programming, and we'll also talk a little bit about some of the other things that you can do in SymPy around queue prioritization and things like that. And then in the afternoon I'm going to show you the wonderful world of cellular automata, as a kind of introduction to agent-based modeling for behavioral modeling. And this is a really interesting kind of magical approach, I think, that's a bit more abstract, but I'd love to see, so my background is in agent-based simulation, and I'd love to see an agent-based, we've never had one, an agent-based project. That would be great if we could have something which sort of models behaviors and how people's behaviors evolve and how that impacts a population. Would be fantastic to see. So yeah, I look forward to showing that. So the morning session obviously is an option session for those who want to come along, and then the afternoon will be a core session in cellular automata. Great. Okay, if that's everything, I will close off there. I'll put up the recording and notes, etc. once they're all ready. And until then, I will see you tomorrow. So have fun, everyone, and see you again. Goodbye.